Hi everyone, welcome in Jizamata Academy. Today we are going to learn free fall. So free fall, we all have experienced free fall during when we are in giant wheel. So जेव्हा आपण आकाश पाळण्यामध्ये बसलेलो असतो त्यावेळेला आपल्याला खाली येत असताना पोटामध्ये गुडगुड गुडगुड होतं. That is because we are in free fall. So let's see what is free fall. So if we release an object from height, it gets pulled towards the earth because of the gravitational force. तेव्हा केव्हा आपल्या हातामधून एखादी वस्तू पडते तर तेव्हा ती बरोबर व्हर्टिकली डाऊनवर्ड पडते जमिनीकडे ओढली जाते बिकॉज ऑफ द ग्रॅव्हिटेशनल फोर्स. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. तर जेव्हा एखादा ऑब्जेक्ट खाली पडतोय but the force acting on it is only the gravitational force. पण तो पडत असताना त्याच्यावरती फक्त आणि फक्त ग्रॅव्हिटेशनल फोर्स ऍक्ट होतोय. फक्त ग्रॅव्हिटेशनल फोर्सचा अट्रॅक्शन आहे म्हणून तो खाली पडतोय. तर त्या वेळेसच्या फॉलला that is called as free fall or to be the object is said to be falling freely. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. So let us look at the kinetic and potential energies of an object of mass m falling freely from height h when the object is at different heights. So let's see what happens to the kinetic and potential energies of an object during free fall. So before going to this, we must know what is law of conservation of energy because free fall is the proof for law of conservation of energy. So according to law of conservation of energy can neither be created nor be destroyed. एनर्जी आपण तयारही करू शकत नाही आणि नष्टही करू शकत नाही. इट कॅन बी कन्वर्टेड फ्रॉम वन फॉर्म इनटू अनदर. ती फक्त एका रूपामधून दुसऱ्या रूपामध्ये रूपांतरित होत राहते, फिरत राहते फक्त. And therefore the total amount of energy in the universe remains constant. पूर्ण विश्वातली total energy remains constant. According to law of conservation of energy can neither be created nor be destroyed. It can be converted from one form into another, and therefore total amount of energy in the universe remains constant. So this law, that total amount of energy during free fall remains constant, we have to prove this. So let us prove the law of conservation of energy with the help of free fall. So during free fall, here in figure you can see an object is at height h from the surface, that is at point A, and it is falling to the ground, that is at point C. So total energy at point A is equal to, before fall, that is when it is just going to fall, at that point, that is at point A, is equal to total energy at point B, which is in between the height edge and the ground. Any point between height and the ground, that is point B, and this total energy it is equal to at point C. That is total energy at point A, B and C is equal. That is law of conservation of energy we have to prove with the help of this free fall. So as shown in figure, the point A is at height h from the ground. So let's prove the law of conservation of energy. So at point A, when object is at point A, it is at height h from the ground. जमिनीपासून h एवढ्या height वरती तो आहे. So let the point be at distance x vertically below A. So from A, the point B, it is at a distance of x. So therefore, the height of B is total height AC, it is h, AB is x, then we can calculate BC as BC is equals to AC minus AB, that is h minus x. Therefore, the height of object at point B is total height minus x. So let the point C be on the ground directly below A and B, and point C, it is at a point where that object is just touching the ground. So let us calculate the energies of the object at A, B and C. So let's go towards law of conservation of energy. Let's prove that total energy at point A is equal to total energy at point B and C. So its initial velocity u is equals to 0 meter per second when the object is falling freely from point A. It is just going to fall. Therefore, its initial velocity is 0 meter per second. Always remember that when object is freely or falling vertically downward, its initial velocity is always 0. Total height is h. So when object is at point A, let's calculate its total energy. When object is stationary at A, its initial velocity u is 0. So when it is at point A, it is just going to fall freely. Therefore, its initial velocity is 0. So kinetic energy of this object at point A will be half mv square. So as velocity is 0 and initial velocity, that is kinetic energy, is equals to half mu square. U because its velocity is initial velocity. So as u is 0, its kinetic energy will also be 0. Therefore, kinetic energy is equals to 0 when object is at point A because it has no velocity. And we all know that kinetic energy depends upon velocity of the object. As velocity is 0, kinetic energy is also 0 at point A. So let's see about potential energy. When object is at height h, its potential energy is mgh. When object is at point A, it is at height h from the ground, therefore its potential energy is mgh. Let's calculate total energy of the object at point A. Therefore total energy is equals to kinetic energy plus potential energy. So kinetic energy is 0 and potential energy is mgh. Therefore total energy of the object at point A is mgh. So to prove the law of conservation of energy, the total energy at point A should be equal to B and C, and therefore we have to prove that the total energy of an object when it is at B is also mgh, and when it is at C it is mgh only. And then only we can prove the law of conservation of energy, that total energy at point A is equal to total energy at point B and is equal to total energy at point C. So when object is at point A, its initial velocity is 0, therefore kinetic energy is 0. As it is at height h from the ground, its potential energy is mgh. Therefore we can say that total energy of the object at height h is total potential energy. It is having no kinetic energy because it is just going to fall. It has no initial velocity. Next, at point B, when object is at point B, let the velocity of the object be Vb. It is having some velocity because it is going to fall. Let us call this velocity as Vb, velocity at point B. When it reaches point B, having fallen through a distance x, it has covered a distance of x. It has reached at point B from A. Therefore, it has covered a distance x. So u is equals to initial velocity is 0 during free fall, s displacement is x, and acceleration is acceleration due to gravity, and as it is falling vertically downward towards the force, acceleration is positive. So let us calculate velocity at point B. So for this we can use Newton's third equation of motion, that is v square is equals to u square plus 2as. Let us put the values. Vb square is equals to u, value of u initial velocity is 0, plus 2as. A acceleration is acceleration due to gravity here, 2gx. That is Vb square is equals to 2gx. So according to formula of kinetic energy is equals to half mvb square. When object is at point B, its velocity is Vb. So let us put the value of Vb square in this equation. We get kinetic energy is equals to half into m into 2gx. So these two in multiplication and division, they will cancel each other, and therefore the equation becomes kinetic energy is equals to mgx. So we have calculated kinetic energy at point B. Let us calculate potential energy when the object is at B. So when object is at point B, its height from the ground is h minus x. So that is, you have to remember, displacement is different and height is different. Whenever we are calculating velocity, we have to consider the displacement, And whenever we are calculating potential energy, we have to determine the height of the object. So when object is at point B, its height is h minus x, total height minus its displacement, how much distance it has covered when it is reaching at point B. So when height of the object when it is at B is h minus x, and therefore potential energy is equals to, according to formula, mgh, height is h minus x. So therefore potential energy becomes mgh minus x. So let's solve this bracket, mgh minus mgx. Therefore potential energy is mgh minus mgx. So you have calculated kinetic energy at point B, potential energy at point B. Let's calculate total energy at point B. Therefore total energy is equals to kinetic energy plus potential energy. Kinetic energy is mgx plus potential energy is mgx minus mgx. So this plus mgx and minus mgx, they will cancel each other, and therefore total energy is mgh. So you from the formula second equation, you can see that first equation and second equation are the same. Total energy is equals to mgh. That is, we can say that total energy at point A is equal to total energy at point B. So let's see total energy at point C. So when object is at point C, let the velocity of the object be vc. It is having some velocity, final velocity, when it reaches the ground near point C. So it is just reaching the ground, and its velocity is vc. So u, initial velocity is 0, displacement, yes, it is complete height, it is reaching the ground, therefore displacement is total height that it has mm, displaced, it has been displaced from. Acceleration is g, acceleration due to gravity. So let's calculate velocity at point C. According to Newton's third equation of motion, v square is equals to u square plus 2as. So vc square is equals to u square, u is 0 plus. So velocity at point C, vc square is equals to initial velocity is 0 plus 2, acceleration is acceleration due to gravity g, and displacement is total height. Therefore kinetic energy is equals to half m vc square. Let's put the value of vc square as 2gh. Kinetic energy, it becomes half m 2gh. These two in multiplication and division, they will cancel each other, and therefore kinetic energy becomes mgh. So when object is just reaching the ground, its kinetic energy is mgh. When object is at this position, at this point C, its height is 0 because it is just reaching the ground. Therefore its potential energy becomes 0, because potential energy depends upon height. As there is no height, there will be no potential energy. So let's calculate the total energy at point C. That is, kinetic energy is mgh and potential energy is 0. Therefore total energy at point C is total kinetic energy, that is mgh. So from equation 1, 2 and 3, we can see that total energy of the object is same at the 3 points A, B and C. So total energy is mgh when it is at point A, when it is at point B, and when it is at point C. So at all the 3 points, the total energy of the object is same. So thus every object has potential energy when it is at a height above the ground. When object is at some height above the ground, its energy is potential energy, and it keeps getting converted to kinetic energy as the object falls towards the ground. When the object starts to fall towards the ground, its potential energy, it is being converted into kinetic energy, and therefore on reaching the ground, that is at point C, all the potential energy gets converted to kinetic energy. All its potential energy, which was earlier when it was just falling freely, at that point it has only potential energy, and this potential energy, it is going to be converted into kinetic energy as it is falling downward. When it is just reaching the ground, so on reaching the ground, its potential energy is completely converted into kinetic energy. It is totally converted into kinetic energy. But at any point during the fall, the total energy remains constant. So at any point during fall, when it is at point H or point A at height H from the ground, when it is in between the height and the ground, and when it is just reaching the ground. The total energy of the object remains constant. So in this way we can prove the law of conservation of energy, that the total energy of the object during free fall remains constant. So that is total energy is equals to potential energy. So always remember during free fall. So there are some things to remember, that during free fall acceleration is always acceleration due to gravity and it is positive acceleration. Initial velocity of the object u is always 0. Therefore displacement is also 0 when it is just starting to fall. When object is at height h, that is at point A, its total energy is total potential energy, because its initial velocity is 0. It has no kinetic energy. Therefore, at point A, that is at height h, its total energy is total potential energy. When object is falling down and it's at any point between A and C, it is at point B, its total energy is sum of potential and kinetic energy. Its total energy is sum of potential and kinetic energy. That is, earlier at height h, it has only potential energy. This potential energy, sum of this potential energy is converted into kinetic energy. And therefore, when object is in between at any point between A and C, its total energy is potential plus kinetic energy. When object is reaching the ground at point C, its total energy is total kinetic energy, as height is 0. As height, there is no height, it is just reaching the ground, it has reached the ground. So at that time its total energy is total kinetic energy, that is, its total complete potential energy is converted into total kinetic energy. So these are the points that we have to always remember. Remember always during free fall. So Newton's equations of motion for freely falling object. So according to Newton's equations of motion, so these equations of motion, they become, or they somewhat change for freely falling object. So like first equation is v is equals to u plus at. As u initial velocity is 0 and acceleration is g, equation becomes v is equals to gt. First equation of motion becomes v is equals to gt. Second equation of motion, that is s is equals to ut plus half at square. As u initial velocity is 0 and acceleration is g, equation becomes s is equals to half gt square. So Newton's equation of motion, second equation becomes displacement s is equals to half gt square. Third equation of motion, v square is equals to u square plus 2s. It is relation between velocity and displacement. But in during free fall, as initial velocity is 0 and acceleration is acceleration due to gravity, so if we put these values, the third equation becomes v square is equals to 2gs. So this is how Newton's equations of motion changes during free fall, or when an object is falling freely, the equations of motion, Newton's equations of motion are as this. So I hope I have cleared all the points about free fall. If you like our videos, please subscribe our channel, press like and share our videos. Thank you very much.